Hi, I'm going to give you a little bit more instruction before you do the next EMF assignment. So I'm going to continue talking about translations of the plane. So let's take a look at this. If P, Q, X, and Y are elements of the plane, we want to know under what conditions it is true that the translation that takes P to Q is equal to the translation that takes X to Y. Well, certainly, if P is equal to X and Q is equal to Y, then the translation that takes P to Q would be the translation that takes X to Y. And remember, when I read this kind of stuff, I always am drawing. So I have a translation that takes P to Q. And it would move all the other points in the plane that direction and that distance. So again, if I know that P is equal to X and Q is equal to Y, of course, this translation will also take X to Q. So that's true. But if I have a translation that takes P to Q, and that's the same translation that takes X to Y, can we conclude that P is equal to X and Q is equal to Y? Well, the answer to that question is no. So you can imagine if I have another point X, I could find that point Y under that same translation that would take X to Y. It moves at the same direction and the same distance. So no, that's not the case. For example, let R and S be elements of pi such that R is not equal to P. Okay, I'm going to keep drawing. So R is not equal to P. And I have a translation that takes P to Q, this one. And if I put in R, I get out S. So in other words, it's going to go the same direction and the same distance again. Approximately. Well, I didn't really draw that very well, but I meant for all of these to be the same length and the same direction. Why does it then follow that S is not equal to Q? Well, look at our picture. If R is not equal to P, clearly S is not equal to Q. But now we're going to say it in mathematical language. Then we see that the translation that takes P to Q is the translation that maps R to S. But the only translation that maps R to S is the translation R comma S. So it follows that the translation that takes P to Q is equal to the translation that takes R to S. That is, T sub P comma Q and T sub R comma S are different names for the same translation, even though P is not equal to R and Q is not equal to S. In this case, T sub P comma Q of R equals S, and T sub R comma S of P equals Q. In other words, the translation that takes P to Q, it takes R to S. And the translation that takes R to S takes P to Q. So the answer to our question is, if T sub P comma Q of X equals Y, then T sub X comma Y equals T sub P comma Q. In fact, for all P and Q in the plane, there are an infinite number of names for T sub P comma Q. So in this case, if you take a look at it, I could name that translation T X comma Y, T sub P comma Q, and T sub R comma S. And really, anytime I find a point in the plane that takes that point to another under this translation, I have a new name. So the next thing I'd like to talk about is the distance between parallel lines. So let me draw two. There's one line. Here's another line. They are parallel. So if I'm going to measure the distance between parallel lines, I have to specify what distance I'm measuring. So for instance, I wouldn't measure it this way. Well, it could, but I'm going to get all sorts of different measurements depending on the 2 points of the lines. So we're going to agree that the distance between parallel lines is this perpendicular distance. Now let's read about this in mathematical notation, and I'll continue drawing. Let pi be a plane. This is in pi. And K and L be lines. Okay, let's name these. This is K. This is L. In pi, such that K is parallel to L. Yep, that's how I have it drawn. And let U be a length. Then the U distance between K and L is the unique distance, which is an element of non-negative real numbers, such that all lines M in pi, such that M is perpendicular to K, D is equal to the distance between K and L, where the intersection of M and K is equal to K, and the intersection of M and L is equal to L. So let me show you what that looks like. I'm going to erase this a minute. So according to this, I have a perpendicular line M. And again, M is perpendicular to K. I have that marked here. And then, of course, I know it's also perpendicular to L, because if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. I'll name this M. And the intersection between M and K is the point capital K. And the intersection between M and L is the point named capital L. Now, the distance between parallel lines is this distance, D. And again, it's non-zero. So we're always measuring the perpendicular distance between lines. So now I'd like you to work on your homework assignment, which includes exercise 205 to 209. I've installed the model answer for exercise 208, and I'd like you to read that for understanding. Have a nice day.